Yo, okay. I think we live. Oh shoot, this is too high. Okay. Okay, I think that's good. Welcome. Hopefully there's no... Hold on. Okay, hopefully there's no echo. Hopefully everything's good. But the plan for today, bro, there's so much coding to do, so much work to do. So much work to do. I just had breakfast and I like this pasta from Piata. Bro, Piata's so good. I don't know if y'all have ever had Piata before. If you haven't, we'll have some Piata, bro. Piata is like so beautiful. I need to fix this lighting issue. Notice how like there's like no light. Oh, whoa. So much light now. But it's a little lighting issue. Second? What about that? Is that any better? No, kind of weird. It's pitch black if I do this. Ugh. Anyways, it'll be fixed tonight, and let me tell you why. I'm getting posters, right? I'm getting posters on my here, I know what I can do. Open with, dang it. But basically I'm getting posters. And in the posters there's where's my stream, bro? Where's my stream? Okay. In the posters basically there are, I don't know what to call it, like, anyways, I'm getting posters and I wanna basically, you can't tell right now, but in the back corner of my room it's just the bed. The bed is just here, right? And I have like these lights here and I have a light underneath my bed. But let me check if the chat is in. The chat is in right now. YouTube. Okay, let me edit. Let me add a Discord in. Discord. Copy. There you go. Yeah, so basically the back corner of my room, there's just nothing there, right? So the plan is that I want to get rid of this thumbnail, bro. I don't want the thumbnail. Change. Can I remove this, please? Anyways, the back corner of my room, there's just nothing there. So my plan is to basically get this light. Let me show you. I have this light bar, this like light bar from, I don't know where it's from. It starts with a G. Govee. I have a Govee light strip. So what I'm gonna do is I'm gonna put that light strip on the top of my, I just realized I can't multitask. Okay, I found it. I'm gonna put this light strip on the top. Like, you know how the light strip is like over here? I'm basically gonna do that, and I'm gonna get posters. So the posters, it's like the bar's gonna illuminate the posters and it's gonna look really nice. Uh-huh. Oh yeah. Yeah, I'm pretty excited about that. And hopefully it turns out good. So right now I'm actually choosing out the posters. But it's on my laptop, so I don't know if I can show you. There's this album called Since I Have a Lover, which I'm putting up, Alone at Prom, of course. And then I'm doing this Frank Ocean album cover, but it's like user made, like a fan made. It looks so good though, so I'm gonna use that as well. I'm gonna get those up and going. I can't put the music I want on stream. That's another issue. It's so depresso espresso, but it's okay. But yeah. Anyways, so I should either do leak code right now or I should learn JavaScript. I'm trying to learn JavaScript. In one of the classes I'm taking, it's really boring, and I low-key already know some of the content, so I'm just trying to like learn JavaScript, I guess. That being said, I just remembered I do have a homework assignment to do, which I think it would be great if I can do it now actually. So let me not share my screen for now because I don't want to actually accidentally share some of my passwords. But okay, this is the assignment, and basically the goal is you need to get these values and in this format with this input. I submitted this assignment so many times, have not gotten it yet. I've gotten this far. So like if I submit it, don't judge me, bro. Don't judge me. But if I submit it, 183.9 when the answer is supposed to be 184, 1.0 when the answer whenever like I have this. So it's like a rounding issue right now, which I'm really frustrated with, because the input's going in fine. Input 1, 900, 6.7, 1, 9.6, 9.76. So yeah, that's the issue right now. I'm gonna go ahead and get this part out because like I need to, and then I'm gonna figure out the rounding issue because it's really frustrating, honestly. And before that, I got this new keyboard also. I got this new keyboard and it's so nice. Hold on. It's a nice keyboard. Let me put this laptop over here. Okay, I'm gonna use the bathroom real quick. But yeah, I shall be back. I'll be back. We're back. So I want to get this out of the way really fast actually. So let's go ahead and let's just start. So I need to type AC in. So we put bulb in percent. We put space. How much space? 1, 2 space. AC with another space. So all of that. Dang it. Percent. Okay, now let's see. Okay, so now the percent value will go in here. So what is the amount of AC would be percent AC would be, this is an assignment for C++ how to do. It would be AC elec divided by total elec. My friend actually got this, but he added certain value. He added like 0.5 to make this like work, which makes sense. But I don't want to. I feel like I don't know. There's definitely a different way to do it, right? Add spacing. Okay. Double percent AC. What else? Percent AC fan AC. Double percent fan. In the highs and lows, it's hard to need to. Okay. Fan elec. Alright. Total elec. Percent fan. So that's that. So now for AC we need to do percent AC. Okay, so for percent, so we put it in the percentage. Then we need to do percent fans. After percent fans, we put in the percent fan. Percent fan, we'll do the actual percentage, which is, yeah, we did that. Then the actual percentage value, then new line. Let's take out that space. Then we do electricity bill for the month. Wait, let me just copy it. Electricity bill for the month. Electricity bill for the month would be, how do you calculate that? Okay, so we do 9.5, is it just multiplied by this? So it would be, hold on. Okay, so it's 9.5 times 368. That's not it. How do we get this, bro? Per unit price of electricity. Let me see. Total usage times price per unit times 0.01. Oh, so is it, so total usage, so add the total usage times price per unit times what? So total usage times price per unit times there. Okay, I think that's not gonna work, but we're gonna check the values now. Okay, so this is the issue. So it's a rounding thing, man. The rounding of this last digit. That's what it is. Oh, not in this case, but it's a rounding issue. Right? Yeah. So for this we want 2. Oh no, we don't always. We want to round to a 10th. For this one, that. Okay, I think I know what to do for that. Oh no, but this one, oh no. So this is a whole number, this is a whole number, whole number, whole number. Okay, so let's just do, okay, how do you round up? Round up C++. Okay, so I guess we just add a plus 0.5 then. So we want that in the beginning for total electricity usage. Plus 0.5. That'll solve that. For the bulbs, oh, we need to, okay, I know what we need to do. So we do that so that we can have 1 decimal point afterwards, and then do the same thing but for 2 now. I think this should fix it. This makes sense. Let's see. Bro. Set precision's not, oh, do we need to import IOMAN IP? Yeah. We got 1. We got that. We got that. We got not this. So it's just this. So that's, oh, because it's still calculating it as a as a double. What if we just do total bill? Where's total bill? Oh, total electricity. What if you just put int? Does that work? It doesn't, so it needs to stay double. Is this a thing? Can you just do that? No, we can't. That's not a real thing. Oh, this is also unnecessary. We can just do dash n. And do the same thing for percentage. Okay. Dang, bro. It's just this. At least we got the rest down though. That's good. Same thing with this. This is fine. This is fine. So it's just a first value. How do we convert? I guess convert a. I know how to convert it to a double, but I don't think technically you haven't learned that in the class, so I can't use it yet. Just see how to round up. Isn't that we just searched up? Yeah. Seal. Round. I see. So we put int in front. So we put what did I miss? Int. Okay, so what if you yeah, that's how it is. Bet. Okay, bet that works. We're done with that. It's not letting me exit out. That's fine. Okay, we're done with that. Now we can. Guess we're not doing that. This is the poster I was getting. You know what? Ooh, but this is kind of nice. Okay, I'll think about that. Let's just add that to my cart. As if I'm gonna buy all of this. Anyways, so I guess now just start coding. So let's go ahead and check that out. Okay, bet. So start coding now. Oh, I forgot it had yogurt here. Okay, so now we do coding time. Time to do the utmost code. Unfortunately, I don't know I'm gonna share that with you guys. Gosh. You can kind of share it, I guess. We'll have to go here and do one of these, like a bet. Okay, so for this, okay, what I'm doing right now is I'm like learning JavaScript, and yeah. Oopsie. Yeah, I'm learning JavaScript, and I'm at, where am I at with it? Hold on, let me move some things around. This keyboard is so nice. Okay, let's exit out of this because we don't need this anymore. With JavaScript, wait, I was at that point. Function basics, that's where I was at. I think I finished function basics though. Thought I did. Okay. So with this, I'm using the Odin project, and it's proven to be pretty useful for me. I do need to I do also need to prepare because I low-key have like an OA to do, and your boy is not ready. Let me go ahead and pull it up. Let's just see what this goes like. Wait, I want to see if y'all can hear my keyboard. Hold on, this is kind of hype. Like, imagine if I get like a keyboard ASMR. Oh, yo, y'all might be in for a treat, bro. Y'all might be in for a treat. Let's just try. Let's try this. So do that, and like if I start typing. I hope that sounds good. I honestly, I really do. Because if it does, we can get the keyboard ASMR, bro. Keyboard ASMR would go crazy. Hopefully. Okay. With that being said though, I think it is time. It's time to check out this OA. See what's going on. Let's see. Here it is. Okay. Okay. Guys, I'm lactose intolerant, and I just had a milkshake like yesterday night, and it is not sitting well. I'm gonna go Chrome. Oh, I need to use the bathroom again, bro. I actually do. I'll be back. My bad, chat. I'm sorry, chat. Okay, let's do some leak code, Loki, before I do this OA. I think if I aim to start this OA at like 2, I think 2 is a good time to start the OA. So, put this back. So, since we're not starting the OA yet, it would be good to do some leak code questions now, not gonna lie. So, let's go ahead and start that. Okay, let's go ahead and do that. So, at 4, we'll take OA. After that, I'll need to go because I need to do some prints. And when is my class today? My class today is at like, what, 7? Oh, shoot. 7, yeah, it says 7. So yeah, that's, as long as we finish by 4. So I'm thinking we just do a recap. Let's just do a recap of everything that I already know. I think that'll set me on track to do well. Roadmap, linked list, reverse, reorder. Reorder is the next step. Haven't done that yet. Okay, that's okay. So we'll do this much. How much have I done total? Can I check? 8 plus 11, 20. Really? Okay, 19. Sorry. That's okay, I guess. Like, it is what it is. Let's go ahead and let me. Go ahead and add something. Okay, bet. Let's go ahead and go to Nico. Okay, we're gonna do this, boy. We're doing this, boy. Okay. Actually, I'm hating this layout. Okay, let's start. So first one is a return of something. Okay, this makes sense also because it's just a hash map or hash set. So hash map, we're gonna make it into a set because a set does not contain duplicates. For n in nums, we're gonna add it to the hash set. Hash map dot add, and we're gonna add the value. We need to check if and in hash map. If it's in the hash map, we're gonna return false. No, return true. Return true. Otherwise, no. Otherwise, return false. Run. It's gonna work. Okay. I know that one because I drilled that into my head. Oh my god. I'm so sorry. Kind of. If length of the first string is not equal to length of the second string, then we're gonna return false because that's obviously gonna be false. What do we do after that? we add each value to what? Oh, a dictionary. Count S, count T. Create 2 dictionaries. And now for, okay, I got it. Well, we only need to use one of them. For each value inside of this, we're gonna, what is it, bro? Hold on. Provide range length S. Is that it? Because we need to count S. Oh, we don't put the I in there, right? Yeah, it's 0. Those are default value. Do the same thing for T. And then return. Right? True, should be true. Oh. Kind of forgot why this works.
Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem
valid anagram,
and
we're actually going to be solving this a few different ways, so maybe you will learn something today. What if we made sure that the characters show up? It's just going to be the character. We're going to do that for every single character.
Oh, we're gonna count the characters in each one, right?
Character in the string. Things like A, N has 1, G has 1, R has 1, and M also has 1.
I need lotion. I'll be back.
Key is the exact same, right? It has 3 A's, 1 N, etc., etc. As we continue this, so in the end, you can see that they're the exact same hash map, right? And once we've built these hash maps, we can then go through the keys and then compare that the counts for each character are the exact same, which in this case, yes, it is. So then, after that comparison, then we know that they're anagrams, then we can return true. And how exactly I'm going to do that is I'm just going to have to iterate through the keys of one of these. So in this case, for example, I'm just going to iterate through all the keys in string S. So A, N, G, and then make sure the counts, right? We want to make sure that the count of each of the characters is the exact same. And if we make sure that both strings have the exact same length, before we actually
Okay, I got it. We just make we check the count of each one in the hash map. Hash map, hash map, hash map, hash map, hash map, hash map. Okay. 1 second. Okay, so for this, we need to Oh, we're returning the indices of whatever adds up to that. So we're gonna go through each indice. So let me write down. I'm not gonna, I forgot it already. I know we initiate both, so yeah, prev map. So prev map is gonna hold the values, right? Prev map would hold the values. We're gonna go through, so for I and enumerate nums. Oh, silly me. Then we're gonna calculate difference, and the reason, so difference is n minus target. Oh, target minus n, sorry. The reason we do target, we're calculating the difference. So we're going through each one, and we're gonna add it to prev map. If it's in prev map, we're gonna calculate the difference. So we're gonna say if the difference is in the prev map, we're going through each one. We're gonna subtract. We're gonna add it. So 3 goes to prev map, subtract, which is 4. When we eventually get there, it will notice that it's in the prev map, so it'll return those two indices. So if it's in the prev map, it'll return the indices of the difference in prev map, as well as the index. And the prev map, and this is what we do to add it. So we're gonna add n into prev map, associate it with the indice. I'm still a little new to all this, so what I'm doing now is I think the best route would be to just explain it to you guys as I do it, and then whenever I do always, we will get better at it, I feel like, right? So next. Okay. We're gonna add the anagrams to. Okay, we're given a list of strings. We're gonna add anagrams to their own substrings. The sublists. I forgot what we make. Oh, because it will create their own. So default dict, I'm pretty sure it creates a new dictionary if it doesn't exist for some values. So in this case, we're going through each string, checking, making a list count of just full of zeros. For each character, we're gonna add it into count with respect of their ordinance. So we're gonna take C, so their character, subtract it by the ordinance of A, because they're all lowercase, and we're gonna add or equal. I don't know why this part is here. Okay, let's check the video.
Hey everyone, welcome back, and let's write some more neat. The characters from A to Z, right? How many does it have of each? So we know it has one E, one A, and it has one T. And for this one, we would see that the exact same thing is true. It has one E, one A, and one T. So if we use a data structure called a hash map in this case, and in this case our key is going to be this one T, well, output is where M is the...
Okay, I get it. We get that character subtracted by the ordinance of A to get its value. We're gonna add or equal it. We're gonna set it. So we're gonna add 1 to it if we discover it for each character in a single string. So in a single string for each character, we're gonna add it in for each character. We're gonna, so if we see P, we add 1, O is 1, T is 1, S is 1. So for this string in count, we'll have 1 of each of these, and that's basically this adds 1 to each of the characters. Res tuple count append as. We're gonna append the string to res, which is our like list here. and tuple count. I forgot why we did that.
Is asked for,
And so we're and then subtract out how many of each character. So we want to map in this case A to index 0, and we want to map Z to index 25. So how can we do that? Well, we can, one way at least, is just take the ASCII value of the current character we're at C, and then subtract the ASCII value of lowercase character a. So as you can see, lowercase a minus lowercase a is going to be 0. Z, lowercase z minus lowercase a is going to be 25. So we do have it correctly because, for example, let's just say a is ASCII value 80, and I don't know if this is actually correct, so it's just a random value. Then b is going to be ASCII value 81, and so on. But if we want to map this to 0, we know one way to do that is take 80 minus 80. If we want to map lowercase b to 1, we can take 81 minus 8, right? So that's basically what I'm doing in case you haven't seen something like this before. And so we're just going to increment this by 1. We're just counting how many of each character we have. And now in our result, we want to add, so for this particular count, we want to add, we want to append, we're going to append this string s. So we want to group all anagrams with this particular count together. Now what if this count does not exist yet? Well, I'm going to change this dictionary to a default dictionary or a default hash map where the default value is a list, so we don't have to deal with one edge case. And also, right now our count is a list, but we know in Python lists cannot be keys, so we're actually just going to change this to a tuple because tuples are non-mutable. But mainly this is Python stuff. You might not have to worry about this in other languages. And so that's actually it. So now in our dictionary, we have grouped together. Now what if 1, we're just counting how many of each character we have, and now in our result, we want to add, so for this particular count, we want to add, we want to append, we're going to append this string s. So we want to group all anagrams with this particular count together. Now what if this count does not exist yet? Well, I'm actually going to change this dictionary to a default dictionary
Forgot what
or
a
a
tuple
default
is.
hash map where the default value is a list, so we don't have to deal with one edge case. And also, right now our count is a list, but we know in Python lists cannot be keys, so we're actually just going to change this to a tuple because tuples are non-mutable.
So they can't be
Mainly
changed.
This is Python stuff. You might not have to worry about this in other languages. And so that's actually it. So now in our dictionary, we have grouped the anagrams together, so we just can take result.values. We don't want the keys anymore. We just want to return the values, the anagrams grouped together, so we can return that, and we're actually finished. So this is the optimal m times n solution, where m is the number of strings we're...
Okay. I'm trying to see if I had notes on this. Okay. Anyways, I get it now. So first we're going to have a default dictionary. Then let's just check out. Let's see. I'm gonna go for each thing is string. We're to a dictionary or a list of zeros by 26 because that's how many are in the alphabet. For each character in S, we're gonna add it to the count by its ordinance. We're gonna add one to it, so it's added to the list. Why is my music not playing? Y'all didn't see that. Anyways. Then we're gonna add this to the list, or I guess in this case it's res. So we're adding the strings together based off their character count, and it's gonna be in their own little list. Then return the values. I am so tired. I'm so tired, but let's continue on, I guess, to the 0 viewers that are watching. Oh wait, I just reminded myself I need to change something. Okay, I need to check the schedule for today. Okay. Okay, so what we're gonna do is what we're gonna do is we're going to, let's see. Given an integer array nums, an integer k, return the most frequent elements in the array. So if k is equal to 2, return the 2 most frequent. So in that case, it would be 2 and 3. Is there what's one most? Okay, it makes sense. It makes sense. I genuinely forgot this. Did I? I really forgot this. So I guess we made a list for each and the frequency that it occurred in to count it at the end of the list. Bro, I'm talking to myself about the problem, man. And then for n and nums, I guess for each value in nums, wait, why is nums there? For each value, oh, nums is a list. I'm goofy. For each value in nums, we are making a hash map of count. Oh, and we're adding 1 to each value. Okay, this makes sense. And then for each, I forgot why this is here. For n, character and count items. Honestly, I forgot this. I can see we're making 2 lists. One is of count, one is of frequency. Let's see the video. Actually, no, I want to show though. So let me count this. This is the part that's confused me. What is frequency? Because doesn't count already count the frequency?
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve top k
frequent elements. I really like this problem because it's pretty clever, and once you figure it out, the code is really easy to write. So we're given an input array nums and an integer k, and we want a algorithm called bucket sort. So when you first think of bucket sort, this is probably what you're going to think of. The way bucket sort is usually taught is that for each value, for example 1, we're going to take an input array, right? This is our input array.
This row is the indices, the index of the array, and this is actually going to be the value. So for example, for 1, we're going to go to the index 1, and in the value we're going to put, okay, 1 occurs exactly once. Now we're going to see a second one, we're going to say 1 occurs twice, right? Basically, we're going to go through the input array, count how many times each value occurs, and then in our input array, put that count for that index, right? Map the value to the index and then put the count of that value. So 1 occurs 3 times, 2 occurs twice, 100 in this case occurs once. Now this algorithm would be linear time if our input values, right, were bounded. For example, if we knew for a fact that every value was between 1 and 10, then we would know that the size of our input, if every single value of which 1 occurs 3 times, 2 occurs twice, 100 in this case occurs once. Now this algorithm would be linear time if...
So I think what's happening here is counts the amount of times it occurs, but frequency is what sorts it into this actual table.
Our input values, right, bounded. For example, if we knew for a fact that every value was between 1 and 10, then we would know that the size of our input array is also going to be 10, right? But in this case, the values are unbounded, right? Like this could have been 1,000,000, and then the size of our input array would have been 1,000,000, even though the total input array size is only 6, right? We have 6 elements, but then that array where we actually store the bucket sort values is going to be unbounded, right? And also, we want the top k elements. This still isn't very clear of where exactly the top k elements are actually going to be. So in this case, this type of bucket sort doesn't work, but there's another way we can do it. So in this case, you can see for our array where we're going to be doing the bucket sort, the index I was using each value in the input array. For example, 1 was being mapped to index 1, right? And that occur 6 times. Why are we stopping at 6 though? Why don't I extend this array farther, right? 7, 8, 100, right? Why do the indices stop at 6? Notice a single value in this case. I have to iterate through 6 linear time again. Because remember, the max size that this array could possibly be is going to be about equal to the size of the input array, right? Because we could have a value, for example, 1 could occur 6 times. In that case, we'd have 1 over here. Now, what if every single value in the input array was distinct, right? That's another extreme. What if we had 1, 2, 3, 4, 5, 6? In that case, this position would be empty because no values occur 6 times, no values occur 5 times, 4 times, 3 times, or 2 times. Every one of these 6 values would go in this position at index 1, reason being each one of these occurs exactly once. So in that case, we'll have all 6 values concentrated over here. And that's still going to be linear time because, yes, we are going to be iterating through this entire input array, which is going to be big O of n, and then we're going to add another big O of n to that, right? Big O of n plus big O of n, because we're going to have to iterate through 6 values in exactly one position. So that's still technically linear time. Now we are creating this array to help us, and we're also going to be needing a hash map to count the occurrences of each value in the input array. So the memory complexity is also going to be big O of n. With that being said, let's jump into the linear time code. It's pretty easy once you can identify this trick. So we are going to use a
La 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 la, I kind of get it.
hash map to count the occurrences of each value. We're also the array, the special array that's going to be the same size as the input array is going to be called frequency. Basically, the index is going to be the frequency of an element or the count of an element, and the value is just going to be the list of values that occurred that particular many number of times. So I'm going to have I'm going to initialize this as an empty array. The number of empty arrays that go in this is going to be about the size of our input plus 1. So now I'm just going to go through every value in nums and just count how many times it occurs. So for count of this particular n value, we're going to do 1 plus what its current count is, count.getN. Now if n doesn't already exist in our hash map or dictionary, we're just going to put a default value of 0. So this will return 0 if it doesn't exist. But this is how we're going to be counting the number of times each value in nums occurs. Next, we're going to be going through each value that we counted. So n, c, in count.items, because that's going to return the key value pair, every single key value pair that we added to our dictionary. And for every key value pair, for every
Okay, this kind of makes some sense. So we count as a list as a hash map. And frequency is the second table. And that's what's going to, and we set it to the last num. So range length of nums goes through each value, but I think it's at the end because, well, we do nums plus 1. Okay, we do for the length of nums. For any nums count. For the length. So we set frequency to the length of whatever that is. Now we're going to count the value for each n in nums. And if we don't have one, we're going to set the default value to 0 for n each character and count. We're going to append these values. We're going to append each character to n. We're making a separate list for results. For the length of frequency, we're going to go to the end of the list, to the beginning. And for each frequency, we're going to append each value, and if it's equal to k, which is the thing, number, and return the value. This is kind of tricky. Yeah, obviously this could run. Oh my god. I didn't like that one. Encode and decode. This one was fun. Let's take a 2-minute break. Let's take a 2-minute break. 2-minute break. Break time. I need to stop. I cannot type like that.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem encode and decode strings. So you can tell the interface is a little bit different this time, and that's because we are going to be solving this problem on LintCode, because this is a premium LeetCode problem and we can solve it for free on the website LintCode. And also, this is a problem from the Blind 75 list, a list of 75 common LeetCode questions that we've been tracking on this spreadsheet. A single string, right? So a naive way would be something like this, right? Just say, okay, neat code. Now the problem is, okay, we did that, the encode was fine, but now we want to decode, not just limited to lowercase a to z. So the difficult thing is going to be, how do we create some kind of delimiter between each word? How do we know when one word ends and another word begins? That's kind of what we're going to be focusing on. So let's get into that solution. So suppose we were given two strings like this, neat and code, and we want to convert it into another string, basically into a single string, right? So a naive way would be something like this, right? Just say, okay, neat code. Now the problem is, okay, we did that, the encode was fine, but now we want to decode this back into the two original strings that we had, but there's no way for us to determine, right? Because we can't remember the limit, separate words. What if we used a pound sign or something, right? Something like this, or any character, maybe a question mark or something, right? But this is like our special character. That's what's going to separate words for us. So in this case, it works out, right? We'll go character by character in the input. Once we get to a pound sign, okay, we'll say that this word ends. So we'll say, okay, we have the first word neat, and this is not included in any of the words. So we skip it, and then we get to the remaining portion, code, and there aren't any more pound signs. So that works out in this case, right? But basically, our assumption when we're using this pound sign is code function. It's a little bit easier. So remember, we're given a list of strings and we want to encode it into a single string. How are we going to do that? Well, we're going to go string by string in the input, and to the result, we want to append this encoded string s. How are we encoding it again? Well, remember, we're going to take the length of the string, and the length of the string is going to be an integer, but we want to transform that into a string. So let's do that in Python pretty easily, just like this. Plus, we want to add the delimiter to the pound sign. So we have the length of the string followed by the delimiter pound sign followed by the string itself s. So then, this is kind of the format that we agreed upon. This is how we're going to be encoding it, because it's going to be easy for us to decode this as well. So we're going to do this for every single string in the input, add it to the result, and then we can go ahead and return that result. So encode was pretty straightforward. Decode is going to be a little bit more tricky, but we know the rules that we can follow. So this time we're given a single string, a single encoded string, which is going to be, encoded using the function that we just wrote. So how are we going to decode it into a list of strings? In this case, our result is going to be a list of strings. And I'm also going to have a pointer I, which is going to tell us what position that we're at in the input string so far. So I'm going to just iterate character by character. So while I is still in bounds, we are going to read character by character, basically decoding each string. So when we start off, the first position that we're going to be at is going to be an integer, right? So what we want to do is we want to find the delimiter. We want to find the end of the integer. So we're going to have a second pointer, j. Initially, it's going to be at I, and while the character at pointer j is not equal to the pound, meaning that we're still at an integer character, we're going to keep incrementing j by 1. And we're guaranteed to find a pound character, right? Because that's kind of how we encoded it up above. So we're going to keep incrementing until we get to that pound character. And then once we get to the pound character, we know that our integer, the length of the following string, is going to be from our string starting at index I, going all the way up until index j, but not including index j, right? So this portion is going to be the integer. Right now it's a string, so we want to transform it into, or convert it into an integer. We can do that in Python pretty easily, just like this. So now this length variable tells us how many following characters we have to read after j in order to get every character of the string. So in other words, if we start string at index j plus 1, because remember, j is at the delimiter character, so j plus 1 is going to be the first character in the string itself, and we want to go all the way until the end of that string. How do we get that? Well, right now we have the length of that string, so we can say j plus 1 plus length. This will give us the entire string. And what do we want to do with the string? Well, we want to append it to the result. So let's go ahead and do just that. So basically, each iteration of this loop is going to read one entire word, and then we're going to go again, loop again, and read more words until we reach the end of the string. But one thing we forgot is, how are we going to update our pointer I? Well, we just read a single word, so now we want to start at the next word. How do we get that? Well, our pointer I is just going to be set to j plus 1 plus length, because this is actually not, this is going to be Hey everyone. welcome back, and let's write some more neat code today. So today let's solve product of array except itself. So this is another problem from the blind 75 list. As you can see, it's over here, product of array except self, so I'm going to be adding that video solution. One way we can break it down is basically get the product of every value before 3 in the input array and get the product of every value after 3 in the array, and then multiply these two values together, and then that's going to give us the value that we would want to put in this position in our result. So it would be helpful for us if we want to do that for every single value in the input array, if we basically just compute the prefix product for every single position in the input array, right? And then put it in a prefix array. And since we're also going to be wanting the product of values after, it would also be helpful if we computed the postfix product of every single position in the entire input array, right? And we can compute both of these in big O of n time. It's a pretty simple algorithm, right? We'd basically start at the first position. Okay, this is going to be 1. So if we're adding this value, we're just going to take the previous value and multiply it by 2. So this is going to be 2. Similarly, we're going to take 2, multiply it by 3. We're going to get 6 here. 4, multiply it by 6. We're going to get 24 here. And for postfix, we're basically going to do the exact same thing and do it in reverse order. So here we would get 4. Here we would get 3 times 4. Here we would get 2 times 12. And then here we just get 1 times 24, which is just going to still be 24. Now for every single values, for example, 1, we would want the prefix of every value before it. Now, since there are no values before it, we can just say, okay, the prefix for that is just going to be a default value of 1 to keep it neutral. And so we'd also want the postfix of every value that comes after it. We can get that in the position to the right of 1. So we'd want to multiply those together. So 1 times 24. So in the output for this, we would get 24. That makes sense because if you multiply all these together, except for this one, we do get 24. And then we just repeat the exact same process for every value. So over here, we'd want the prefix of the values that come before it, and we'd want the postfix of the values that come after it. So 1 times 12 is just going to be 12. That's going to be the output. Again, repeat the same thing for here. The prefix is 2, postfix is 4. We're going to get 8 as the output. That makes sense. If you take 24, if you take every value in here, multiply it except for 3, we do get 8. And similarly for this 4, we'd want the prefix 6, and the postfix, there are no, so we just assume that there's a 1 over here. So 6 times 1, this would be the output. So this is a very valid solution. This is a big O of n time solution. We're not using any division operator, but the downside is this is also big O of n memory, but we can actually use this idea because what they tell us is the output array does not count as extra memory, so we actually don't need these prefix and postfix arrays, because we can compute these prefixes and postfixes and then store them in our output array, and that is going to end up making things easier for us because we're not going to have to use this extra postfix prefix memory. So what we're going to do is we're going to do 2 passes on our input array nums. First, we're going to start at the beginning and then go all the way to the end, basically computing every single prefix for the input array and then storing the prefix of
Okay, I think I'm gonna call it for today. I do have to do an OA, so I'm gonna go ahead and do that. And then I'll probably stream later tonight if I can, but I think we made decent progress. I had good review on the lead code questions. And then yeah, I'm gonna do my OA, run some errands, class, and then if I have time, I'll stream when I come back. Sounds good. Thank you guys for watching, and I'll see you tomorrow or tonight. Bye.